this week and a little bit next week. And our goal is to understand how probability of an event indicates its likelihood or its chance that it's going to happen. Okay? So, like when you're talking about weather, and they talk about it's an 87% chance of rain today. That's the likelihood that it's going, that's the probability, and then we look at the likelihood that it's going to rain. Okay, if you're playing a game, let's say, I'm not condoning it, but like if you ever go to Vegas, you go to the casinos, you know, like the slot machines, what's the probability you're going to win from the slot machine? Okay, well, they're kind of rigged, and you're most likely not going to win something, but or playing the lottery. Y'all seen like the lottery signs on the side of the road where it's like the Mega Millions and it's humongous amount.
Wheel of Fortune.
Yeah, the Wheel of Fortune. Okay, so we're going to be talking about probability, and there's a lot of vocabulary that goes with probability. So as we write these down, you might want to highlight them with your highlighters as we write them, so that you know, oh, this is vocabulary. This is important. All right. So our first word is and blank is an investigation or a procedure that has varying results, and that is an experiment. Where else do you see an experiment? In the science lab. What we're doing the next 2 chapters is involved in science heavily. Okay, we're going to be looking at data and statistics. And we get those data and those statistics through running an experiment, just like you would in science. This is kind of where science and math meet. Okay, so that's an experiment. The possible results of an experiment is called an outcome.
Sure, we're getting this down.
The possible results of an experiment are called outcomes. So like the combinations from the rock, paper, scissors game that we just did, those were the combinations that the possible outcomes. A collection of one or more outcomes is known as an event. And then if we're asking the outcome of a specific event, like what's the possibility of getting rock and rock, that's called a favorable outcome. Okay, a favorable outcome. So you have an example at the bottom of your page with some colored marbles. Okay, let's pretend these marbles are in a bag. And we're going to randomly choose marbles out of the bag. Randomly choosing a marble from a group of marbles is known as an experiment. We're conducting an experiment when we're trying to test to see what color am I going to get. It's like a test. Each marble in the bag is a possible outcome. Because each one of these guys have a chance of being picked, right? When you put your hand in that bag, you have a chance of picking the red marble or the green marble or the blue marble or the purple marble. Well, there's not purple up on here, but...
What's our chance of pulling a purple marble out of this bag? 0? Well,
Yeah, 0, because there's not one, right?
possibly.
Alright, selecting a green marble from the group would be an event. Okay, so those are all our key words that we're going to be talking about today that we're going to need to put into practice. Okay? Alright, so on to the next page. You see these letter tiles here? Let's pretend these letter tiles. Oh, so we're not on letter tiles yet. We're on the spinner. Okay? So we have this spinner. But we have to pay attention to what the question is asking. The question says, how many possible outcomes are there? How many tells me I'm looking for a number. How many possible outcomes?
1.
So if I were to spin the spinner, how many places are there for my spinner to land?
6.
6. So, like, if I were to list my possible outcomes here, the possible outcomes on this spinner are 1, 2, I could spin another 1, I could spin a 3, I could spin a 1, and I could spin a 4. I could spin any of these parts, right? Well, how many outcomes are there? 1, 2, 3, 4, 5. So there are 6 outcomes.
Some of those outcomes are the same, but 6 total outcomes.
Okay, the next question is, what are the favorable outcomes of spinning an even number? The what are the favorable outcomes are asking me, okay, what is it going to be? So we're looking at even numbers. So if I were to split my list into even numbers, what's the opposite of even? And odd. Okay, if I were to split my list into even and odd, I've got 1, is 1 even or odd? Odd. Okay. And then I've got a 2, which is even. And then I got a 1. And then I got a 3. Got another 1. And then I got a 4. Okay? Those are my favorable outcomes. Those are the favorable outcomes for even, and these are the favorable outcomes for odd. Which ones do we want to know? Even. So my favorable outcomes are, and it's not asking for how many, it's asking what are they. 2 and 4 are the possible outcomes, favorable outcomes for being even. What would be the favorable outcomes if they were odd? 1, 1, 3, 1. Okay, good. In how many ways, so how many, we're going to be counting, can spinning a number less than 2 happen? 3 ways, right? Well, what's our numbers less than 2? 1, and 1. So there would be 3 ways to spin a number that is less than 2. Okay? So now let's look at the letter tiles. It says you randomly choose one of the tiles shown from a hat. How many possible outcomes are there?
8.
Well, how many different tiles are there?
8.
8. So there's 8 possible outcomes. So that's a how many question. This is a what are they? What are the favorable outcomes of choosing a vowel? So this is where what are our vowels? Okay.
These 3.
Okay, but they want to know. It's not asking how many. It's asking what
8.
are they? So A, what?
8.
A, E, and A. These are my vowels. Those are the only way I could draw a vowel out of the hat. If I could pull an A, I could pull an E, or I could pull another A. And how many ways can you choose a consonant? Okay, so it says how many ways. It's going to be counting. Well, consonants are not vowels, so how many are not vowels? 1, 2, 3, 4.
Oh, gosh.
5. 5 ways. Okay. I want you to try the spinner part. Pay attention to the questions that it's asking. You spin the spinner shown. How many possible outcomes are there? Write it down. What are the favorable outcomes of spinning a number no greater than 3? And how many ways can you spin an even number? And how many ways can you spin a prime number? Try answering those questions. All right. How many possible outcomes are there? 8 possible outcomes. Good. What are the favorable outcomes of spinning a number no greater than 3? It's asking what are they? Is 3 no greater? Okay, 3 is equal, but we're looking for the ones that as long as it's not greater than 3. Is 3 greater than 3?
Yes. No.
So can I use 3? Yeah. 3 would be considered no greater than 3. How many ways can you spin an even number? What are even numbers here? 2, 4, 6, and
8.
Oh, I didn't know that was.
all right, so there's 4 ways. Okay, then the next one asks about a prime number. What are prime numbers? They're not necessarily odd. They only have 2 factors. 1 in itself. So I can only multiply by 1 and that number to get that number. That's the only way I can do it. So,
It has to be more than 1. Can't be more.
okay. Okay, 1 and 3.
7.
I did that.
Is there another one?
Is it 2?
All right, if it's 2, what's the different ways we can multiply to get 2? 2 times 1. Is there another way to get 2 times 1? No. So 2 is also prime. 1, 2, 3, 5, 7, 11, 13, 17, 23, 29, and it just goes 31, goes on like that. So how many of them were prime? How many outcomes were prime? There are 5 possible ways. Okay. How do we feel about this? Easier than the last stuff we did? Okay. Alright, flip it over. Alright, we've got a new bag of marbles we're looking at. It says you randomly choose 1 marble from the bag. Find the number of ways the event can occur for part A. And then part B, find the favorable event outcomes of the event. So part A is find the number of ways. How many ways can we get it? And part B, what would those ways be? So choosing blue. How many ways can we choose blue? Two ways. And to choose blue, we either have to choose a blue or a blue. How many ways are there choosing green? One way. The only way to choose a green is to choose a green. Alright? Choosing purple. Two ways. What are those two ways? Purple and purple. Choosing yellow. Alright, this is where it gets a little different. Choosing not red. How many different ways can you choose not red? 1, 2, 3, 4, 5, 6, 7. No, there's a red one. My bad, sorry. 6. So I said that's not the number I got the first time. 6 ways. Gracie was right. 6 ways. What are those 6 ways?
Green, yellow, purple,
I could pick a green one. I could pick a yellow one.
blue,
I could pick a blue one. I could pick another blue one.
purple.
I could pick a purple. Or I could pick another purple. Those are the 6 different ways I could pull not a red marble. What are the different ways in not choosing blue? There's 7 ways to not choose blue. And those would be what?
Green,
I could pick a green,
yellow,
a yellow. I could pick a purple.
red,
I could pick another purple. I could pick a red, another red, another red. Not blue. I don't want to pick a blue, right? Alright, does that make sense so far? Okay? Alright, we're going to scroll down and look at some critical thinking questions here. It says, tell whether the statement is true or false. If it is false, change the italicized word to make the statement true. Alright, spinning blue and spinning green have the same number of favorable outcomes on spinner A. What do we think? Spinning blue and spinning green have the same number of favorable outcomes on spinner A. So here's spinner A. What are the number of favorable outcomes of spinning blue? 2. What's the number of favorable outcomes of spinning green? 1. So is this true or false? False. Alright, so we need to change the green to what other color gives me the same favorable outcome as blue? Red. Good. Okay, because what's the favorable outcome of red? 2. There are 3 possible outcomes for spinning on spinner A. Alright, you're saying?
What's our key word there?
Alright, how many outcomes are in spinner A? How many different sections are there? 1, 2, 3, 4, 5. So this is saying that there are 3. So is this true or false? False. And so instead of 3, it should be 5.
What are there 3 of? 3 what?
Everywhere.
different colors.
Colors.
3 different colors.
But is colors and outcome the same thing?
Yes.
Alright, spinning red can occur in 4 ways on spinner B. True. Spinning not green can occur in 3 ways on the spinner, in spinner B.
Close. Yes.
Alright, so here's spinner B. Here and here, green. The rest are not green. How many ways is that?
2.
1, 2, 3, 4, 5, 6, 7, 8 ways. Alright, so just like we did up here, how many ways of not choosing blue? There were 7 ways. Down here, not choosing green, there were how many? 8 ways.
Main
So,
further, if it's like door, like, there's 3 colors you could pick except for one.
yeah, that's true. So that's not what the question was asking, was it? I like the way you were thinking, Tom. Okay, so that's looking at outcomes. Listing the outcomes. Alright, so turn the page.
You'll see Coach Jones' favorite chart of all the favorite charts that we learned about in school.
Alright, we're talking about probability. Here's another key word. The probability of an event is a number that represents the likelihood that the event will occur. So likelihood is the same thing as what is the chance? Or what are the odds that it would happen? You ever watched the Hunger Games before? So, any of y'all seen the Hunger Games? The movies, the Hunger Games? Some of you?
But that little quote they always say.
May the odds be ever in your favor. It's not a very Hunger Games. Anyways, it's a movie. You can go look it up. But basically, all the kids' names that when they reach a certain age go into a lottery pot, and they draw your name. They draw a boy and they draw a girl to go participate in the Hunger Games. Okay, and so what's the probability of your name being picked out of all the girls? What's the likelihood? What's the odds? What's the chance? And so they say, may the odds be ever in your favor. Anyways, so probability is rated between a 0 and a 1, so we can count it as a percentage. Okay? And then we have this beautiful diagram down here that tells us what the likelihood, based off of the probability, it would be of it happening. Okay? So, here, if the probability is 0% chance of rain today, then it's going to be impossible for it to rain. If it's 100% chance of rain, it's for certain to happen. If it's 50% chance of rain, there's an equally likely to happen versus not happen. Okay? If it falls between those two, it's probably unlikely to happen. Okay? It could happen, but there's a really big chance that it's not going to happen. Okay? And then there's, when it's closer, when it's between these two, you have it to likely happen. It's not a guarantee,
Like it's not gonna rain that much.
okay? Or like, if you study really hard, it's likely that you're going to do good on the test. It's not a guarantee, but it's likely to happen. If you don't study for the test, then it's unlikely for you to do well on the test. Okay? So let's look at this forecast since we've had some nasty looking weather anyways. So our forecast is that there's an 80% chance of rain. There's a 50% probability of thunderstorms. And that there's a 15% chance of hail. Okay? We want to know, and this is the forecast for tomorrow, what is the probability of rain? Well, first we're looking at what is the likelihood that it's going to rain tomorrow. So to figure out the likelihood, we have to look at the probability. So what's the percentage of rain that we have here? 80%. So the probability of rain tomorrow is 80%. What is the likelihood that that event's going to happen? Look at your diagram. Which one is it closest to? It's closest to 75%, which is, so the likelihood of the event happening is that it is likely to happen because the probability is close to 75%. Okay? We want to know what's the likelihood there are thunderstorms tomorrow. All right, what's the probability of thunderstorms tomorrow? The probability is your percentage, is 50%. So what's the likelihood going to be? Well, if you look up here, 50%, it's what? Equally likely to happen, or there's an equal chance that it will happen and that it won't happen. So equally likely to happen or not happen because the probability is 50%. It's a 50-50 chance. It's got just enough chance to rain versus just enough chance not to, or to thunderstorm. All right, what is the likelihood that there's going to be hail tomorrow? The probability would be 15%. So what's the likelihood that it would happen? It's unlikely. Now, is it completely impossible? What would it have to be completely impossible for it to hail tomorrow? 0%. But because there's a little percent, there's a chance, but it's very unlikely it's not going to happen. Like snow. Okay, you know how sometimes they're like, there's a possibility of snow. Most of the time it's unlikely to happen. What were you going to say?
It says like, rare things have like a rare species, like a 1 in a million.
Yeah. Right. You could also look at what we're doing. Could also look at those Punnett squares y'all did in science. What's the likelihood that the baby's going to have blue eyes, or have curly hair, or have freckles, or be a boy, or all those kinds of things. Okay. All right. So look at these situations. It says describe the likelihood of an event given its probability. The probability that you land a jump on a snowboard is 1 out of 10. Well, this isn't a percent, but what can we do to the fraction? We change it to, what can we do? If it's a fraction, what can we do if we're supposed to have percentages? We could change it, right? So if I've got 1/10, I could put it in my calculator and change it to a percent, or a percent is out of 100, right? What do I have to multiply 10 by to get to 100? 10. Whatever I do to the bottom, I got to do to the top. So 1 times 10 is, so this is a 10% chance. Okay?
If you don't know how to do that, you type in your calculator, you type in 1/10 and go to go to your second and convert to fraction decimal. So you hit your green button, and then you hit the table button. And that converts your 1/10 to a decimal.
Alright, so 10%, is that impossible, unlikely, equally likely, likely, or certain? Which one would that be? 10%, where would that lie?
Unlike,
Unlikely to happen.
I like that.
I mean, that would be like if I went to go snowboard, okay? But my percentage would be way lower. Like, I'm probably going to face plant if I were to even try and make it down the mountain on a snowboard. There would probably be a very likely chance that I would break something. Gracie, too. Probably 100% chance. She can be fragile sometimes. Alright, there's a 100% chance that the temperature will be less than 120 degrees Fahrenheit tomorrow. What's the likelihood of that happening?
Certain.
If my percentage is 100%, and I look back over here, 100%, it's for certain not going to be more than 120 degrees tomorrow. Your soccer wins 3/4 of the time. 3/4 as a percent. Well, if I needed to make it out of 100, I would do 4 times 25, and 3 times 25 would give me 75. So I'm looking at 75%. Where does 75%? What's the likelihood with 75%?
very likely.
Likely to happen. It's just likely to happen. There's a 0% chance you'll grow to be 12 feet tall.
Impossible.
If it's 0%, it's impossible. The probability that the sun rises tomorrow is 1.
Oh, what's that?
Anyway,
Likely to go from,
So, let's go everybody take a look at, you can look on your
Right.
paper.
because it goes from 0 to 1, and 1 is certain, so it goes
equally like,
certain, and
Certain.
Certain.
So
1 is a whole.
What does that represent in your percentages? One represents 100%. Okay, now take a look at the other parts. Remember, all the other ones are what?
Fractions.
Decimals or zero. See those? See you have 1, 7,500, 500, 1,500, 2,500, or 0. Right? Okay. So all those are just what? By the way, I tell you what, if you took those numbers and you converted them to percentages, what would it be? Let's say you took 0.75 and converted to a percent, what's that going to look like? Alright, so if you take 1 and convert it to a percent, it's going to be 100.
Okay. It's a whole, which 100 is a whole. So it is for certain that the sun's going to rise tomorrow. It rains 1/5 of the days in June. If the probability is 1/5, if I convert that to a percent, so over 100, 5 times 20, so 1 times 20, so 20% is what likelihood? It's unlikely. And that's all we did for today. Okay? So your homework tonight is off of this. You're going to want to take your notes. You're not packing up because you still got 12 minutes before the bell or so. You can knock out your homework. So I would get your homework out. And your homework questions are very similar to the examples we did in our notes. So I would go back and look at our notes and compare. It's like on your homework, numbers 1 through 2. the try it with the tiles. Okay? Numbers 1 through 3 are like page 2. 4 through 7 are like this page right here.
Wait, what is that?
Two- 1 through 3 is like page 2. 4 through 7 are like examples numbers 3 through 8, where we had the part A and part B. And then 8 through 11 is the likelihood thing that we just did. Okay? So look at your notes and work on your homework.